Hello everyone, today we are going through exercise 10.3. First question, find the angle between two vectors, vector A and vector B with magnitudes root 3 and 2 respectively, having vector A dot vector B is equal to root 6. So here scalar product of two vectors is given. We have to find the angle between these two vectors. Okay, so here we have, let theta be the angle between vector A and vector B. Let theta be the angle between vector A and vector B. Okay, we have theta is equal to cos inverse of vector A dot vector B divided by modulus of vector A into modulus of vector B, right? So here we need to find, okay, it is given, right? Vector A dot vector B is given and their magnitudes are given, right? So here directly we can substitute cos inverse of vector A dot vector B is root 6 divided by modulus of vector A, that is magnitude of vector A is root 3 and modulus of vector B, magnitude of vector B is 2. So it can be written as cos inverse of root of 6 by 3, right? Root 6 divided by root 3 can be written as root 6 by 3, right? Into 1 by 2. This 1 by 2, okay? That is equal to cos inverse of, here root 6 by 3 is root 2. Root 2 divided by 2, that is nothing but cos inverse of 1 by root 2. Cos inverse of 1 by root 2. When cos is 1 by root 2? Cos 45 degree, that is pi by 4, right? Cos pi by 4 is 1 by root 2. Therefore, cos inverse of 1 by root 2 is pi by 4. Therefore, angle between vectors, vector A and vector B is pi by 4. Second one, find the angle between the vectors I minus 2j plus 3k and 3i minus 2j plus k. Here two vectors are given, we have to find an angle between them. So for that, let vector A is equal to I minus 2j plus 3k and vector B is equal to 3i minus 2j plus k. Okay, then we have a formula, we have to find an angle between them, right? So theta be the angle between them and we have theta is equal to cos inverse of vector A dot vector B divided by modulus of vector A into modulus of vector B. So we need to find scalar product of these two vectors, right? So vector A dot vector B is equal to, vector A is I minus 2j plus 3k dot 3i minus 2j plus k. That is equal to, here we know that a1 b1 plus a2 b2 plus a3 b3, right? That is here 1 into 3, 3 plus minus 2 into minus 2, 4 plus 3 into 1, 3. That is 10. Okay, we have got vector A dot vector B is equal to 10. Next we need to find modulus of vector A and modulus of vector B. That is magnitudes of vector A and vector B. So modulus of vector A is equal to, vector A is equal to this one. So its modulus, its magnitude is square root of 1 square plus minus 2 square 4, 3 square 9, right? 1 square is 1. Okay, that is square root of 14. Next let's find modulus of vector B, that is equal to square root of 3 square 9 plus minus 2 square 4 plus 1 square 1, that is also square root of 14. Okay, now let's find theta, angle between vector A and vector B. Therefore theta is equal to cos inverse of vector A dot vector B is 10 divided by square root of 14 into square root of 14. That is equal to cos inverse of 10 divided by root 14 into root 14, that is 14 itself, right? So 14, that is equal to, reduce it, cos inverse of 2 5s are 2 7s are 5 by 7. It's not a standard angle, therefore you write cos inverse of 5 by 7 itself. Okay. So angle between given vectors is cos inverse of 5 by 7. Find the projection of the vector I minus j on the vector I plus j. We have to find two vectors are given. We have to find projection of the vector I minus j on the vector I plus j. Okay. So here projection of the vector, not projection vector, these are different. Okay. Projection of the vector is a scalar quantity and projection vector is vector. Okay. So here first of all let's take, let A is equal to, vector A is equal to I minus j and vector B is equal to I plus j. I plus j. Okay. We have to find projection of the vector A on vector B. Right. And we have a formula, projection of vector A on vector B is equal to vector A dot vector B divided by modulus of vector B. Okay. So here we need to find vector A dot vector B and magnitude of vector B. Okay. Remember, projection of vector A on vector B is equal to vector A dot vector B divided by modulus of vector B. Okay. Now, find vector A dot vector B. Vector A is I minus j dot I plus j. 1 into 1, 1 plus minus 1 into 1, minus 1. That is equal to 0. We have got vector A dot vector B is equal to 0. Next we will find modulus of vector B, that is square root of 1 square, that is 1 plus 1 square root of 2. Right? Okay. Now we will find projection of vector A on vector B. So projection of vector A on vector B is equal to vector A dot vector B divided by modulus of vector B, that is equal to 0 divided by root 2, that is equal to 0. So projection of vector I minus j on the vector I plus j is 0. Similar question. Find the projection of the vector I plus 3j plus 7k on the vector 7i minus j plus 8k. So here also let's take vector A is equal to, let vector A is equal to I plus 3j plus 7k. And vector B is equal to 7i minus j plus 8k. Okay. Then we have to find projection of vector A on vector B. Right? So for that we need to find vector A dot vector B. So let's find vector A dot vector B. That is I plus 3j plus 7k dot 7i minus j plus 8k. That is equal to 1 into 7, 7, 3 into minus 1, minus 3 plus 7 into 8, 56. That is equal to 60. Okay. Next we need to find, we have to find the projection of the vector A on vector B, right? So we need to find modulus of vector B. Modulus of vector B is equal to square root of, it is the vector B, 7 square 49 minus 1 square plus 1 plus 8 square 64. That is equal to 50 plus 64 square root of 114. Right? Okay. Next we will find projection of vector A on vector B. Projection of vector A on vector B is equal to vector A dot vector B divided by modulus of vector B. That is equal to 60 divided by square root of 140. Show that each of the given three vectors is a unit vector. 1 by 7 2i plus 3j plus 6k, 1 by 7 3i minus 6j plus 2k, 1 by 7 6i plus 2j minus 3k. Okay, first question is, here we have to prove these three vectors are unit vectors. What is the speciality of unit vectors? The magnitude of a unit vector is 1. Right? So here we just show that magnitude of, that is modulus of this vector is equal to 1. Okay. Now let's find. For that, let's take vector A is equal to 1 by 7, 2i plus 3j plus 6k. And let vector B is equal to 1 by 7, 3i minus 6j plus 2k. And vector C is equal to 1 by 7, 6i plus 2j minus 3k. Okay, then let's find one by one modulus of vector A. Okay, if modulus of vector A is equal to 1, then we say that vector A is a unit vector. Okay, that is modulus of vector A is equal to square root of, here 1 by 7, 1 by 49, or you can write separately. Okay, 2 by 7, square of 2 by 7, 4 by 49, plus square of 3 by 7, 9 by 49, plus 6 by 7 square is 36 by 49. That is equal to, see, 4 plus 9, 13, 13 plus 36, 49, right? Okay, so square root of 49 by 49, that is equal to square root of 1 is equal to 1. Okay, so modulus of vector A is equal to 1. Therefore, vector A is a unit vector. Okay, next let's find vector modulus vector B. Okay, that is equal to square root of 3 by 7 square is 9 by 49, 36 by 49, 4 by 49. It's also square root of 49 by 49 is equal to 1. Okay, next modulus of vector C, that is equal to square root of 6 by 7 square is 36 by 49 plus 4 by 49 plus 3 by 7 square is 9 by 49. It's also 1. Okay. Now, here we have got modulus of vector A is equal to 1, modulus of vector B is equal to 1, modulus of vector C is equal to 1. That means vector A, vector B and vector C are unit vectors because their magnitudes are 1. Okay. Next question is, show that they are mutually perpendicular to each other. See, mutually perpendicular means, here suppose it is vector A, it is vector B. They are perpendicular means their angle is 90 degree or pi by 2. Right? Theta is equal to pi by 2. And we know that vector A dot to vector B is equal to modulus of vector A into modulus of vector B cos theta. Right? If these two vectors are mutually perpendicular, that means their angle between them is pi by 2. Right? So here A dot B will be modulus of vector A into modulus of vector B into cos theta, that is cos 90, cos pi by 2 is 0. Therefore, A dot B is 0. Okay. Therefore, here we have to show that scalar product of these two vectors is equal to 0. Then we say that these two vectors are mutually perpendicular. Okay. These three vectors are mutually perpendicular to each other. Okay. So here we have to show, okay, first of all, A dot B. Vector A dot vector B. That is equal to, here vector A is this one, right? Okay. So here 1 by 7, 2y plus 3j plus 6k dot 1 by 7, 3i minus 6j plus 2k. That is, here 1 by 7 is common. So let's take it out. 1 by 7 into 2 into 3, 6 plus 3 into minus 6 minus 18. 6 into 2 plus 12. That is equal to, here 18 minus 18, 0. Right? So it is 0. See, we have got vector A dot vector B is equal to 0. Therefore, vector A and vector B are perpendicular. Okay, because perpendicular vectors, their angle between perpendicular vectors is 90 degree, right? That is pi by 2. Therefore, cos theta, cos pi by 2 will be 0. That is where A dot to B will be 0. Therefore, here we have got vector A dot vector B is equal to 0. Therefore, here we can say vector A and vector B are perpendicular. Okay, next let's take vector B and vector C. Here we have to show these three vectors are mutually perpendicular to each other. Okay, next we will find vector B dot vector C. Okay, so vector B dot vector C. So 1 by 7, 3i minus 6j plus 2k dot 1 by 7, 6i plus 2j minus 3k. Okay, let's find 1 by 7 is common, so let's take it out. Then 3 into 6, 18, minus 6 into 2, minus 12, plus 2 into minus 3, minus 6. 18, minus 12, minus 6, minus 18, 18 minus 18, 0. It's also, we have got it is 0. That is, vector B dot vector C is equal to 0. Therefore, vector B and vector C are perpendicular. Okay, perpendicular vectors. Next, we will find vector A and vector C. Okay, that is vector A dot vector C. Here also 1 by 7 into 2i plus 3j plus 6k dot 1 by 7 vector C is 6i plus 2j minus 3k. That is equal to 1 by 7 is common. 2 into 6, 12. 3 into 2 plus 6. 6 into minus 3 minus 18. 12 plus 6, 18. 18 minus 18, 0. So here also we have got vector A dot vector C is equal to 0. Therefore, vector A and vector C are perpendicular. Okay. So these three vectors are mutually perpendicular to each other. Find modulus vector A and modulus vector B if vector A plus vector B dot vector A minus vector B is equal to 8 and modulus vector A is equal to 8 modulus vector B. Okay. So here we have to find the value of modulus vector A and modulus vector B. These conditions are given. Okay. That is vector A plus vector B dot vector A minus vector B is equal to 8. Let's expand this one. Okay. That is vector A dot vector A, vector A dot vector A, vector A dot minus vector B, that is minus vector A dot vector B. Okay. Next, plus vector B dot vector A minus vector B dot vector B. That is equal to 8. That implies, see here, these two terms. We know that vector A dot vector B, vector A dot vector B is equal to vector B dot vector A. It is commutative. Okay, vector A dot vector B is equal to vector B dot vector A. Therefore, these two terms are cancelled, right? Minus A dot B plus B dot A. That is minus A dot B plus A dot B. Okay, so it is these two terms are cancelled. So next, vector A dot vector A. Here we know that vector A dot vector B is equal to modulus of vector A into modulus of vector B into cos theta, right? If it is vector A dot vector A, what is the angle between them? That is same thing, right? So here angle is nothing but 0, right? So here vector A dot vector A, therefore their angle is 0, that is modulus vector A in place of B, A itself, modulus of vector A into cos 0 is 1, okay? So it is nothing but modulus vector A square. Okay. So vector A dot vector A is equal to modulus of vector A whole square. Okay. So here This can be written as modulus of vector A square. And minus, similarly, vector B dot vector B is equal to modulus vector B square. That is equal to 8. Okay. We need to find value of vector A, modulus vector A and modulus vector B, right? So, one more condition is given. Modulus vector A is equal to 8 modulus vector B. So, let's substitute. Modulus vector A is equal to 8 modulus vector B. So, modulus vector A whole square is 64 modulus vector B square, right? So, let's substitute here 64 modulus vector B square minus modulus vector B square is equal to 8. Why? Since modulus vector A is equal to 8 modulus vector B. Okay, substituted this modulus vector A is equal to 8 modulus vector B here. Okay, 64 minus 1, that is 63 modulus vector B square is equal to 8. That implies modulus vector B square is equal to 8 divided by 63. Okay, that implies modulus vector B is equal to root 8. That is root of 8 divided by 63. Next, what is modulus vector A? Modulus vector A is equal to 8 into modulus vector B is this one, right? So, square root of 8 divided by 63. So, it is the answer. Value of vector A is 8 into square root of 8 by 63 and modulus of vector B is equal to square root of 8 by 63. Evaluate the product 3a minus 5b dot 2a plus 7b. Okay, let's find 3a minus 5b dot 2a plus 7b. Expand this. 3a, 3 into 2, 6. 6 into vector A dot vector A. Vector A dot vector A. Okay. Next, plus 3 into 7, 21. Vector A dot vector B. Vector A dot vector B. Next, minus 5 into 2, minus 10. Vector B dot vector A. Vector B dot vector A. Okay. Then, minus into plus, minus 5 into 7, 35. Vector B dot vector B. Vector B dot vector B. Okay. Here 6 into vector A dot vector A is nothing but modulus of vector A square. Right? Plus here vector A dot B is equal to vector B dot A. Right? So I will write one more step. 21 vector A dot vector B minus 10 vector A dot vector B, because vector B dot vector A is equal to vector A dot vector B, right? Okay, minus 35 vector B dot vector B is modulus vector B square. That is equal to 6 modulus vector A square. Here 21 minus 10 is 11. So plus 11 vector A dot vector B minus 35 modulus vector B square. Find the magnitude of two vectors, vector A and vector B, having the same magnitude and such that the angle between them is 60 degree and their scalar product is 1 by 2. Okay, what are given? Angle between two vectors, vector A and vector B is 60 degree and their scalar product is 1 by 2. We have a formula including these quantities is vector A dot vector B is equal to modulus of vector A into modulus of vector B cos theta. Right? Here vector A dot vector B is given and theta is given. Right? Okay. Now it is 1 by 2 is equal to modulus of vector A into modulus of vector B into cos theta, that is cos 60 degree. Okay, cos 60 means pi by 3. So 1 by 2 is equal to modulus of vector A into modulus of vector B. What is cos pi by 3? Cos 60 degree is nothing but 1 by 2, right? So 1 by 2. Okay. Then take this 1 by 2 here, and it is given vector A and vector B having the same magnitude. Having the same magnitude. That means vector A, modulus vector A is equal to modulus vector B. Okay. That is A and B having the same magnitude means modulus vector A is equal to modulus vector B. So here we can write, okay, take this 1 by 2 here, so it will be 1. Okay. Then modulus vector A into modulus vector A. Okay, because since modulus vector A is equal to modulus vector B, it is given they having the same magnitude. Okay. Then here modulus vector A square is equal to 1. That implies modulus vector A is equal to 1. And modulus vector B is also 1. Find modulus vector x if for a unit vector A, vector x minus vector A dot vector x plus vector A is equal to 12. It is given we need to find modulus of vector x, and it is given that vector A is a unit vector. That is modulus of vector A is equal to 1. That is magnitude of vector A is 1. Okay. So first of all, let's expand this. Vector x dot vector x. Okay. Vector x dot vector x and vector x dot vector A plus vector x dot vector A minus vector A dot vector x. Okay. Minus vector A dot vector A. That is equal to 12. Okay. What is it? Vector x dot vector x is nothing but modulus vector x square. Right? See here, vector x dot vector A, vector x dot vector A minus, here we know that vector x dot vector A is equal to vector A dot vector x, right? So this can be written as vector x dot vector A, right? Okay, minus modulus vector A square is equal to 12. Okay. Now these are cancelled. Okay. Then modulus vector x square minus, here it is given vector A is a unit vector. Okay. Therefore modulus vector A is equal to 1. Okay. Therefore it is 1 is equal to 12. So modulus vector x whole square is equal to, take this 1 here, so it is 30. That implies modulus vector x is equal to square root of 30. Okay. We have to find modulus vector x, that is value of the modulus vector x. So modulus vector x is equal to square root of 30. If vector A is equal to 2i plus 2j plus 3k, vector B is equal to minus I plus 2j plus k, and vector C is equal to 3i plus j are such that vector A plus lambda vector B is perpendicular to vector C, then find the value of lambda. The given condition is vector A plus lambda vector B is perpendicular to vector C. We know that if vector A is perpendicular to vector B, then vector A dot vector B is equal to 0. Okay. So here also vector A plus lambda vector B is perpendicular to vector C. Therefore vector A plus lambda vector B dot vector C is equal to 0. So that we can find the value of lambda. Okay. So here, so first of all let's find this one. Okay, vector A, B, C are given. So vector A plus lambda vector B is equal to 2i plus 2j plus 3k plus lambda into vector B, that is minus I plus 2j plus k. Okay. That is equal to, here 2 minus lambda adding these vectors, 2 plus into minus, that is 2 minus lambda I, okay, plus 2 plus 2 lambda j, next 3 plus lambda k, okay. Now we have got vector A plus lambda vector B is equal to this vector, okay. Next, it is since vector A plus lambda vector B is perpendicular to vector C, A plus lambda vector B dot vector C is equal to 0. Why? Because it is given that vector A plus lambda vector B is perpendicular to vector C. Therefore, their scalar product is 0. Okay. Now, let's find scalar product here. Vector A plus lambda vector B is nothing but this one. Okay. That is 2 minus lambda I plus 2 plus 2 lambda j plus 3 plus lambda k dot vector C. Vector C is 3i plus j. 3i plus j. That is equal to 2 minus lambda into 3 into 2 minus lambda plus 2 plus 2 lambda into 1, 2 plus 2 lambda into 1, okay, that is equal to, okay, it is equal to 0, right? Okay, their scalar product is 0, dot product is 0. So here this, it is equal to 0. Okay, let's simplify this one. Simplify. 3 into 2, 6 minus 3 lambda plus 2 plus 2 lambda is equal to 0. That implies minus 3 lambda plus 2 lambda, that is minus lambda. 6 plus 2, 8. So, minus lambda plus 8 is equal to 0. That implies lambda is equal to 8. Okay. So, we have got the value of lambda is equal to 8. Show that modulus vector A into vector B plus modulus vector B into vector A is perpendicular to modulus vector A into vector B minus modulus vector B into vector A for any two non-zero vectors vector A and vector B. Here we have to prove this vector is perpendicular to this vector. For that we have to show scalar product of these two vectors is 0, right? Because we know that if vector A and vector B are perpendicular, then vector A dot vector B is equal to 0, right? So here we need to show scalar product or dot product of these two vectors is 0. Okay, for that let's find dot product of these two vectors. Modulus vector A into vector B plus modulus vector B into vector A dot modulus vector A into vector B minus modulus vector B into vector A, right? So here first term modulus vector A into vector B dot modulus vector A into vector B. Next term minus modulus vector A into modulus vector B into modulus vector B, vector B dot vector A, vector B dot vector B. Okay. Next term is this one. Here also, see here modulus of vector A and modulus of vector B, that is a real number, right? Magnitude of these vectors, that is a real number. Okay. So here we can take it out and then we can write A dot B, vector A dot vector B or vector B dot vector A. Okay. So here next term is modulus vector B, modulus vector A, modulus vector B into modulus vector A, vector A dot vector B, vector A dot vector B. Okay. Next is these two, right? Minus modulus vector b into modulus vector b, that is modulus vector b into modulus vector b, vector a dot vector a, vector a dot vector a. Okay. So here also we can write, see first term also, modulus vector a, because it's a real number. Okay. Modulus vector a, vector b dot vector b. Okay. Vector b dot vector b. Then it is equal to, here modulus vector a square, what is it? Vector b dot vector b, that is nothing but modulus vector b square, right? So modulus vector b square minus, here see modulus vector a into modulus vector b, modulus vector b dot vector a. We know that vector a dot vector b is equal to vector b dot vector a, and it is, the sign is plus minus, so it is cancelled, right? So next term is minus modulus vector b square into modulus vector a square, because vector a dot vector a is modulus vector a square. Okay. So that is equal to, see, it is equal to 0. Okay. Now we have got scalar product of these two vectors is 0. That is, this product, this vector modulus vector a into vector b plus modulus vector b into vector a is perpendicular to modulus vector a into vector b minus modulus vector b into vector a. If vector a dot vector a is equal to 0 and vector a dot vector b is equal to 0, then what can be concluded about the vector b? See, here vector a dot vector a is equal to 0 implies that vector a is a 0 vector. Okay, if vector a dot vector a is equal to 0, then if vector a dot vector a is equal to 0, that implies that vector a is a 0 vector. That is, vector a is equal to 0 vector. And vector a dot vector b is equal to 0 for any vector b. Vector b. So here vector b is any vector. Okay. Therefore vector b is any vector. Because here vector a is a 0 vector and vector a dot vector b is equal to 0. That implies vector b is any vector. Okay. If vector a, vector b, vector c are unit vectors such that vector a plus vector b plus vector c is equal to 0, find the value of vector a dot vector b plus vector b dot vector c plus vector c dot vector a. How to find the value of this vector? See here, it is given that vector a plus b plus c is equal to 0. Okay. So here we can apply a property, that is a property of vector. Vector modulus of vector a plus vector b plus vector c whole square is equal to modulus of vector a square plus modulus of vector b square plus modulus of vector c square is plus 2 into vector a dot vector b plus vector a dot vector c plus vector b dot vector c. In real numbers we have an identity, right? A plus b plus c whole square is equal to a square plus b square plus c square plus 2 into ab plus bc plus ca, right? Similarly in vectors also we can write, or if you find the derivation, okay, if you do the derivation of a vector a plus vector b plus vector c dot vector a plus vector b plus vector c, you will get the same thing. Okay. So here, now let's apply. It is given that vector a plus vector b plus vector c is equal to 0, means it's a 0 vector. So what is the magnitude of 0 vector? 0 itself, right? So here modulus of vector a plus vector b plus vector c is nothing but 0, right? Why? Because vector a plus vector b plus vector c is a 0 vector. Okay. So since vector a plus vector B, vector C is equal to 0, 0 vector. So modulus of vector A plus vector B plus vector C is equal to 0. Therefore, their square is also 0. Okay. And it is given vector A, vector B, vector C are unit vectors. Therefore, their magnitudes are 1. Okay. Therefore, since vector A, vector B, vector C are unit vectors, modulus of vector A, modulus of vector B, modulus of vector C is equal to 1. Okay. Then, let's apply these values in this equation. So, left side 0, LHS 0, that is equal to 1 plus 1 plus 1, 1 plus 1 plus 1 plus 2 into vector A dot vector B plus vector B dot vector C plus vector C dot vector A. Okay. Then, so here 3, take this 3 left side. So, minus 3 is equal to 2 into vector A dot vector B plus vector B dot vector C plus vector C dot vector A. Okay. So, here vector A dot vector B plus vector B dot vector C plus vector C dot vector A is equal to minus 3 by 2. If either vector A is equal to 0 or vector B is equal to 0, then vector A dot vector B is equal to 0. But converse need not be true. Justify your answer with an example. Okay. So here, if either A is equal to vector A is equal to 0 or vector B is equal to 0, we know that vector A dot vector B is equal to 0. So what is the converse? So here, let's assume converse vector A dot vector B is equal to 0. Vector A dot vector B is equal to 0 implies modulus of vector A into modulus of vector B into cos theta is equal to 0. Why? Because vector A dot vector B is equal to modulus of vector A into modulus of vector B into cos theta, that is equal to 0. Okay. This implies either vector A is equal to 0, either vector A is equal to 0 or vector B is equal to 0 or cos theta is equal to 0. Okay. So, cos theta is equal to 0 implies vector A perpendicular to vector B. Cos theta is equal to 0 implies vector A perpendicular to vector B. For example, here vector A is equal to 12i plus 3j 4i minus 12j plus 3k. Okay. And vector B is equal to 3i minus 4j plus 12k. So let's see what is vector A dot vector B. That is 4 into 3, 12 minus 48 plus 36. That is 48 minus 48, 0. See, here vector A dot vector B is equal to 0. Vector A and vector B are perpendicular and their dot product is 0. When if cos theta is equal to 0. Okay. So, here we can say thus two non-zero vectors, vector A and vector B may have vector A dot vector B is equal to 0. Okay. So, here for two non-zero vectors, vector A and vector B may have vector A dot vector B is equal to 0. If the vertices A, B, C of a triangle ABC are 1, 2, 3, minus 1, 0, 0, 0, 1, 2 respectively, then find triangle ABC. Okay. Vertex A is 1, 2, 3. Vertex B is minus 1, 0, 0. vertex C is 0, 1, 2. Here we have to find the angle of B, that is angle ABC. So for that, here we will find, okay, first of all let's write the vectors, position vector, vector OA, vector OB, vector OC from the origin, okay. So here vector OA is equal to, so A is the vertex 1, 2, 3, right? Therefore vector OA is equal to I plus 2j plus 3k, right? Okay, then vector OB is equal to minus I plus 0j plus 0k. Next, vector OC is equal to 0i plus j plus 2k. Then, here we have to find the angle of B, right? That is angle ABC, right? So for that, here let's find the vector BA and vector BC. Okay? So let's find vector BA. What is the vector BA? By the triangular law of vector addition, here we can write vector BA is equal to vector OA minus vector OB. Right? Vector BA is equal to vector OA minus vector B. Okay? By triangular law of vector addition. Okay? These things all we have already studied. So vector BA is equal to vector OA minus vector B, because here vector BA plus vector OB is equal to vector OA. Therefore, vector BA is equal to vector OA minus vector B, vector OB. Okay, let's find. What is vector OA? This one, right? So I plus 2j plus 3k minus vector OB is minus I plus 0j plus 0k. That is equal to 1 minus minus 1, 2, 2 minus 0, 2, okay, 2i plus 2j, 3 minus 0, 3k, okay. It is vector BA. Next, vector BC. Find vector BC. Vector BC is equal to vector OC. It is also by triangular law of vector addition. Vector OC minus vector OB. Okay, vector BC is equal to vector OC minus vector OB. Okay, so it is equal to, so vector OC is 0i plus j plus 2k minus vector OB is minus I plus 0j plus 0k. That is equal to 0 minus minus 1 plus 1 plus I. Okay. 1 minus 0 is 1 minus 1 minus 0. So 1. So plus j. 2 minus 0, that is plus 2k. It is vector BC. Okay. We have to find the angle of B, right? That is angle ABC. And we have a formula, that is vector A. We know that theta is the angle between vector A and vector B. Then vector A dot to vector B is equal to modulus vector A into modulus vector B cos theta. Right? So here also it is the angle ABC is the angle between vector AB and vector BA and vector BC. Right? This angle is angle between vector BA and vector BC. So here we can write the dot product. Vector BA dot vector BC. Okay, these are the two vectors. And what is the angle? Angle ABC. Okay. That is equal to, so dot product of these two vectors is equal to modulus vector BA into modulus vector BC into cos angle ABC. Okay, angle ABC is nothing but this angle. Okay. Now, we need to find the angle, right? So, here we can write cos of angle ABC is equal to vector BA dot vector BC divided by modulus of vector BA into modulus of vector BC. Now we need to find dot product of these two vectors, that is vector BA dot vector BC and their magnitudes. Okay. So let's find vector BA dot vector BC. Vector BA is 2i plus 2j plus 3k dot vector BC is I plus j plus 2k. That is equal to 2 into 1 2 plus 2 plus 6, that is 10. So vector BA dot vector BC is equal to 10. Next is magnitude of vector BA. Modulus of vector BA is equal to square root of, here vector BA is 2 square 4 plus 4 plus 9, that is square root of 8 plus 9 17. Okay. Next, modulus of vector BC is equal to square root of 1 square 1 plus 1 plus 4, that is square root of 6. Okay. Therefore, cos of angle ABC is equal to 10 divided by root 17 into root 6. Okay. Now what is the angle? We need to find the value of angle, right? So angle ABC, right? So angle ABC is equal to cos inverse of 10 divided by root 17 into root 6. Okay. Angle of ABC is equal to cos inverse of 10 divided by root 17 into root 6. Show that the points A of 1, 2, 7, B of 2, 6, 3 and C of 3, 10, minus 1 are collinear. So collinear points means they should be lying in the same line, right? Their vectors are parallel. Okay. So here, let's prove that these three vectors, these 3 points are lying in the same line, or these 3 vectors are, points are collinear points. Okay. So for that, we have to find vector AB and vector BC. So for that, we need to find vector OA. Okay, vector, what is vector OA? From the origin, that is I plus 2j plus 7k. Position vector, vector OA is equal to I plus 2j plus 7k. And position vector, vector OB is equal to 2i plus 6j plus 3k. And vector OC is equal to 3i plus 10j minus k. Okay. Now let's find vector AB. What is vector AB? By triangular law of vector addition, vector AB is equal to vector OB minus vector OA. Okay. That is equal to vector OB minus vector OA. That is 2 minus 1, 1. So I. 6 minus 2, 4. So 4j. Plus 3 minus 7. Minus 4k. Okay. Vector AB is equal to I plus 4j minus 4k. And what is vector BC? Or vector AC. Okay. Let's find vector AC. Vector AC is equal to vector AC, that is here also by triangular law of vector addition, vector OC minus vector OA. That is equal to vector OC minus OA. Okay. So 3 minus 1, 2. So 2i plus 10 minus 2 plus 8j minus 1 minus 7. So minus 8k. Okay. So here see this one we can write, take 2 outside. So 2 into I plus 4j minus 4k. That is 2 into vector AB. See, it is nothing but vector AB, right? Okay. So here 2 into vector AB. So here see we have got vector AB and vector AC are parallel vectors. Okay, vector AB and vector AC are parallel vectors and A is a common point. Therefore, points A, B and C are collinear. Okay, so here vector AB and vector AC are parallel vectors, because here vector AB is the vector AC is the scalar product of vector AB, right? So here vector AB and vector AC, okay, it's clear that vector AB and vector AC are parallel vectors and A is a common point. Thus A, B and C are collinear. Show that the vectors 2i minus j plus k, I minus 3j minus 5k and 3i minus 4j minus 4k form the vertices of a right angled triangle. So let ABC are the vertices of triangle. Okay. We have to prove this triangle is a right angled triangle. So for that here by Pythagoras theorem, here we know that in right angle triangle ABC, we know that AC square is equal to AB square plus AC square. So we have to prove this one. Okay, let's find the vectors. Okay, these three are the vertices of triangle. Then what is position vector of A? That is vector OA. Vector OA is, let A is equal to this one. Okay, B is equal to this vector, C is equal to this vector. Then vector OA is 2i minus, okay, it is the vector OA, okay, position vector. It is already given. It is the position vector 2i minus j plus k, position vector of A, and vector OB, position vector of B, I minus 3j minus 5k, and vector OC is equal to 3i minus 4j minus 4k. Okay, already vectors are given. So vector OA, that is position vector of A, is this one. Position vector of B, I minus 3j minus 5k. Position vector of C is 3i minus 4j minus 4k. Okay, now let's find vector AB and vector BC. Okay, and vector CA. Okay, so let's find vector AB. Vector AB is equal to, what is vector AB? Vector OB minus vector OA, right? That is equal to vector OB minus vector OA. OB is this one, OA is this one. So 1 minus 2 minus I minus 3 minus minus 1, that is minus 3 minus minus 1, that is minus 3 plus 1. So minus 2j, and minus 5 minus 1 minus 6k. Okay, so vector AB is equal to minus I minus 2j minus 6k. Next, vector BC is equal to, sorry, here vector BA, okay, vector BA, that is vector BA, vector BC, then vector CA, okay. Vector BA is equal to, vector BA is equal to vector OB minus vector OA, okay, vector OB minus vector OA, OA minus OB. Okay, so 2 minus 1, 1 I, minus 1 minus minus 3, that is minus 1 plus 3, so plus 2j, and 1 minus minus 5, so please plus 6k, okay, plus 6k. So it is vector BA. Then vector BC, okay, vector BC is equal to, vector BC is equal to vector OC minus vector OB. By triangular law of vector addition, vector OC minus vector OB. So vector OC is this one, right? So OC minus OB. So 3 minus 1, 2i, okay. Minus 4 minus minus 3, that is minus j. Here minus 4 minus minus 5, that is plus k, okay. So here we have got vector BA, vector BC, then we need to find vector CA, okay. Vector CA, that is equal to, vector CA is vector OA minus vector OC. Vector OA minus OC. So 2 minus 3 minus I, minus 1 minus minus 4, that is minus 1 plus 4, so plus 3j, 1 minus minus 4, that is 1 plus 4, so 5k. So it is vector C. Now let's find the magnitude of these vectors, that is length of these sides. Okay, length of the sides, that means magnitude. So magnitude of vector BA is equal to, here let's find its a square, okay, because we have to prove this one, right? Okay, let's take the square, that is 1 square, because it's a square, right? So square root will be cancelled. So it is 1 plus 2 square 4, 4 plus 36. So here 36, 5 plus 36, 41. Okay. Next is modulus of BC, vector BC square. That is magnitude of BC square. It's a square. Okay. So here it is equal to 2 square 4 plus 1 plus 1. That is 6. Next is modulus of vector CA square is 1 plus 9 plus 25. That is 10 plus 25, 35. So here, see, we can write it as modulus of vector BA square is equal to, see, it is 41, that is equal to modulus of vector BC square plus modulus of CA square. Okay, it is clear that modulus of vector BA square is equal to modulus of vector BC square plus modulus of CA square, because 35 plus 6 is 41, right? So here we can write modulus of vector BA square is equal to modulus of vector BC square plus modulus of vector CA square. By Pythagoras theorem, here we can say it is these vectors form a right angle triangle. If vector A is a non-zero vector of magnitude A and lambda is a non-zero scalar, then lambda into vector A is a unit vector if lambda, these options, lambda is equal to 1, lambda is equal to minus 1, A is equal to modulus of lambda, A is equal to 1 by modulus of lambda. Okay. Here lambda into vector A is a unit vector, then modulus of lambda into vector A is equal to 1. Right? Its magnitude is 1. That implies modulus lambda into modulus vector A is equal to 1. Here, what is modulus of vector A? It is given vector A is a non-zero vector of magnitude A. That means modulus of vector A is equal to A. Right? That implies modulus of lambda into A is equal to 1. That implies here A is equal to 1 by modulus of lambda. So, lambda into vector A is a unit vector when if A is equal to 1 by lambda. So, D is the correct answer.